quadratic or exponential? It's exponential. Very good. Way to remember that. So this was exponential. It got exponentially smaller, right? Everybody?
Yep.
All right. What was B? How did you know it was linear? Because of why? Sorry. Oh, you're saying you took differences of the y values? That's a smart method. So you took your differences of your y values and you got that minus that's negative 5, negative 7 minus negative 2, and negative 12 minus negative 7, negative 5. So you said that because the differences were the same after the first time you got it was linear, right, everybody? How many got that one right? Good. All right, what about this one? How do you know it's quadratic? It's a U shape, right? And you're right, it's an upside down parabola, but a U shape will be a quadratic. Okay, what about this one? Good. How do you know it was linear? It doesn't have a square. What else? Okay, that's one method of doing it. So you could graph it and look at it. Another thing to realize, guys, isn't it degree 1 over x? Doesn't that automatically make it linear? Okay, good. And then what about this one? How do you know it's quadratic? Good, it's got degree 2 as your highest degree. And what about this one? And you do that because what? Yeah, your exponent is x. Therefore, it would make it exponential. Very good. Way to go, guys. Okay. So first of all, today we're going to be talking about, we're going to be solving systems of equations. And today we're going to be, so systems of equations just means you're going to be solving two equations at the same time. So today we're going to be solving systems with linear equations and quadratic equations. So we're going to have a linear equation, a quadratic equation, and we're going to solve when they're the same thing. So once again, when solving a system of equations, you're finding what x, y points make the equations true at the same time. So right here, for example, is a quadratic. Y is equal to x squared plus 2. We have y is equal to x plus 2. It's linear. So we want to know what x, y points make the line and the quadratic true at the same time. It'll make more sense in a second. So with that being said, next one here. I think it's the same one. Yeah, so I wrote that up here. So starting with problem number 1 on your worksheet, I have y is equal to x squared plus 2, and I have y is equal to x plus 2. So I went ahead and graphed the parabola right up here. So look with me. I graphed the parabola here. And then I graphed my line. Y is equal to x plus 2. Does everybody see how I graphed it? We want to know where these two, this line and this quadratic, are equal, where they intersect. So everybody, do you see that you can see that they're intersecting? Yes. All right, so we want to know what x, y points make the equation true at the same time. So it really means where are they equal. So looking at this, where do they intersect? At over 0 up 2. So there's one of our solutions, over 0 up 2. They intersect at that point. And then we're looking at the point, they intersect, kind of hard to see from probably where you're sitting. They're intersecting right there, so it's over 1 up 3. So let me show you what it means. So you guys understand these are x, y points, right? So look, if I plug that in to these functions, we know x is 0, y is 2. So let's say we plug in 0 for x. So 0 squared plus 2. What do we get? 2. Was that our y value? So did that one work? Okay, well it better work at the same time here. So let's plug in 0 for x. So 0 plus 2 is 2. Do you see how y came out to be 2? So you can kind of check your answers. It's got to work in both equations. So do you see how we solve for x and y, where it will work in both equations? Okay, sweet. And we just did it using graphing. All right, so I could plug in 1 and the same thing would happen. You'd come out with 3. You could plug in 1 right here and you come out with 3. Does everybody understand what we're doing here? A little bit.
Yeah. Okay,
so now we're going to actually we're going to use our calculator real quick. I'm going to show you how to use your calculator to find those two intersection points. So pull out your graphing calculator. Go to y equals. So go to y equals. And I'm going to type in my first equation, which is x squared plus 2. So I type in x squared plus 2 into y1. That's our first function, right? We had y is equal to that. Now my second function is y is equal to x plus 2. So I type that into y2. Y is equal to x plus 2. So I typed them both in. Is everybody comfortable with that? Then I hit graph. So looking at my graph, we have our line, we have our quadratic, and couple things to notice here. Let's say that you can't really see very good. You're zoomed out too far. It's all scrunched together. Make your window smaller. So here's our window key. You can make your window smaller if you need to, or bigger. So I have mine right now at -5 and 5, and then y max at -5 and 5. Does everybody see how you can change your window if you wanted to? Okay, just so that you can see in closer. If you make it smaller, then you're zooming in closer, right? If you make it bigger, you're zooming out. Is everybody comfortable with that? All right, so now I'm going to hit graph again. So we want to know where these two things intersect. So I'm going to do, on my calculator, second trace. And then we want to know where they intersect, because we want to know where they're equal. So we go down to intersection. And I hit enter. Now it's going to say first curve. So it's intersecting at two places. It's roughly right here and right here. Do you see how it's roughly right there? So we've got to do this 2 different times. I'm going to first find this intersection point. I'm going to scroll and be really close to that intersection point. Do you see how I'm somewhere close? Now look, it says I'm on the quadratic. Does everybody see how it says right here that you're on the quadratic? So it's saying first curve. I'm on the quadratic and I'm close to the intersection point. So I hit enter. Now it's saying second curve. Notice it switched me to my line. So that's our second equation, and we're close to the intersection point. So I hit enter again. Now it says, do you want me to guess? You do want it to guess, so hit enter again. So you have an intersection point of, and if you have a really advanced calculator, don't let this mistake you, so you all need to pay attention. Some people's calculators will say 0,2. How many calculators say 0,2? Awesome, that is correct. But look at my calculator. It says 2.40 e to the -14. So mine's being really, really exact. Remember what e to the -14 means. It means times 10 to the -14. Remember that? So that would be taking our decimal and moving it back 14 places. 0.000000000000002. Isn't that pretty much 0? Does everybody understand that? So we would say it's 0. Okay. So it's really 0,2. It's just these way advanced calculators, they get too technical. Is everybody okay with that? So it's 0,2. That was one of the intersection points we got. Does everybody see that? Okay, let's find the other one, because people tend to have a hard time finding the second intersection point. So everybody do this with me. You have to do it again. Second trace. We're finding the intersection point. So you hit intersect again, just like we did a second ago. And now it says first curve, but I need to now scroll and be closer to the second intersection point. So I'm going to scroll left. I need to be closer to the second intersection point. Do you see how now I'm closer to the second intersection point? And I'm on the quadratic, so I hit enter. And it automatically will put you on the other equation. So now I'm on the line. And I'm close to the intersection point, so I hit enter. It says, do you want me to guess? So you hit enter again. It's intersecting at 1,3. So that would be our other answer, 1,3. There's our two answers where these equations are equal. Does everybody see how to do it using your calculator? All right. So if it says e to the -20, that's 0, right? Think about it. That's taking your decimal and moving it a million places backwards, so that would make it 0. All right, so I want you to do these problems using your calculator. 1 through 6, ready, set, go. Solve these. In fact, 9 out of 10 times, I do not use a calculator. I'd rather just do it by hand and know in my heart that I did it right, because then I'm good to go. No calculator malfunctions. Calculators are great to check answers, though. So now I'm going to teach you how to do it by hand. Not necessarily by elimination or substitution. We're just going to go through and simply solve this using algebra. So everybody look up here. Number 7 says we have y is equal to x squared, y is equal to x plus 2. So we have a line and a quadratic. Aren't they both equal to y? So then, isn't it true to say that if they're both equal to y, y is equal to y, right? So aren't they equal to each other? So we are saying x squared is equal to x plus 2. Does everybody understand why? And now we can go through and algebraically solve. Well, we're going to be solving a quadratic. So we've got to first make sure it's at equal to 0. So I'm going to subtract x. So I have x squared minus x is equal to 2. We've got to make it equal to 0. So then I'm going to subtract 2. So I have x squared minus x minus 2 is equal to 0. Then from there, it's just a quadratic. We're just solving the quadratic. You can use any method of choice. I'm telling you, these are all factorable. Factoring is the quickest way and most efficient to not mess up. So if you can solve by factoring, that's the best way. So look, isn't this quick factoring? So we're looking for what multiplies to be a times c, which would be negative 2, 1 times negative 2, and adds up to be b. b is negative 1, right, everybody?
Yes.
So then we're listing out factors of 2. 2 times 1. It needs to add up to be negative 1. Which one's negative?
2.
And then check it. Is negative 2 times positive 1 negative 2? And then negative 2 plus 1 is negative 1. Now because our a value is positive 1, only if it's positive 1, you can quick factor it. So we throw in our parentheses, we put our x in, we put our factors right in. And it was positive 1. Now the whole point of factoring is so that we can set our factors equal to 0 and solve, right everybody? So we'll say x minus 2 is equal to 0, and we'll also say x plus 1 is equal to 0. Now solve for x in each case. So I'm going to add 2, x is equal to 2. And I'm going to subtract 1, x is equal to negative 1. Now remember, because these are systems of equations, our points of intersection are what we're looking for. So these can't be our final answers. We have to write them as x, y points. So our answers are 2, question mark, and negative 1, question mark. Now if we want to know the y value at that x value, can't we just plug that back into our function? And we can plug it into either. So I just always pick the easiest. But either one, we'll come out with the same answer. Let's plug it in here. What's 2 squared?
4.
So our answer is 4. We've got the same thing here. 2 plus 2 is?
6.
What's 2 plus 2? 4.
Yeah.
Okay?
Negative 1.
Alright, so negative 1 squared is negative 1 times negative 1. What do we get?
1.
And negative 1 plus 2 is?
1.
1. So do you see how this would be your final answer? Okay. X, Y points. One more, then I'll just let you work. The rest of the time is yours. Number 10. So we have y is equal to negative x squared plus 4x minus 3. We have y is equal to negative x plus 1. Because they're both equal to y, then they must be equal to each other. So that's the first thing I'm going to do. I'm going to say x squared plus 4x. Oh, it's negative x squared plus 4x minus 3 is equal to negative x plus 1. Now everybody, I need you to focus on this next piece so that you know what's going on. I want to be able to quick factor. If I bring this stuff over, aren't I still going to have a negative x squared? Therefore, I can't quick factor. We still know how to do it, but couldn't I bring these this way? Can't you? Why not, right? So let's bring these this way. So I'm going to add x squared to both sides. So then I have 4x minus 3 is equal to positive x squared minus x plus 1. Is everybody following me?
I don't know why you did that.
Well, Braylon, you can move this way or this way. It doesn't matter which way you go.
Could you still solve it if you moved all 3 of them at one time? Because I don't like quick factor.
Yeah, me neither.
Well, you can move it either way. So I'm just doing it this way to make it easier on myself. So then, from here, I'm going to subtract 4x, right? We need it to be equal to 0. So we have x squared, we have negative 3 left, is equal to x squared minus 5x, people, plus 1. Is everybody following me? We've got to make it equal to 0, so I'm going to add 3. Add 3. So I have 0 is equal to x squared minus 5x plus 4. And now it's set equal to 0. Does everybody see why I did that? So then we can factor it. And it's quick factoring, yay. So because it's positive 1. So we're looking for what multiplies to be a times c, which is 4, and adds up to be b, which is negative 5. 1 times 4, right? They're both negative. Negative 1 plus negative 4. Yep, it works in both cases. So this quick factors to be an x, and a -1 and -4. And now we set each of those equal to 0 and solve. So x minus 1 is equal to 0, x minus 4 is equal to 0. So we get x is equal to 1, x is equal to 4. So our answers are in points though. So once again, I have 4 comma something, I'm going to find out, and I have 1 comma something, right? Plug it back into either equation, you'll get the same answer. So I'm going to plug it into the easiest. I'm going to plug it in right here. So we have -4 plus 1. You see that I'm putting the 4, which is -3. If you plug in 4 here, you will get -3. I'm going to plug in 1 now, in for x, into the easier equation. So I'm going to have -1 plus 1. 0. If you plug in 1 up here, you'll get 0. There's my final answer. That's the points of intersection. So this is how to do it algebraically. Now these are the problems I need you to do by hand, algebraically. Then you could check them using your calculator if you want, but I want to see you do it by hand. Problem 7 through 12 by hand. Ready, set, go. The rest of the time is yours.